And here we go. All right, you guys, while we wait for a few more people to join, I'm gonna start with the boring part. My name is Nada El Nunu. I'm your instructor for this course, obviously, if you haven't guessed that already. I know you're probably nervous about like learning math online. I know I would be, but I want you guys to know that I plan on making sure that you guys understand the material and make sure that you can see the progress we do, like the steps we're gonna follow step by step. Some instructors are gonna use like PowerPoint slides, but I don't think pointing to a problem while you describe it is how math is done. So I'll be using a DocCam program where you can see my handwriting. So I think that would help make it learning math a little easier, even though it's online. I'm gonna use the first few minutes of class to maybe just like show you Blackboard and where to find everything, since everything is virtual. Let me see. Share my screen. Okay. So right now you're gonna see something weird. There you go. This right here is what I see, and you see on my screen what I see, and so on and so forth. That's why it looks like a big kaleidoscope, but ignore that. I want to start with announcements. Okay, so this is the Blackboard page. I click on the other page. This is the Blackboard page. This is where I'll be posting any announcements or anything I want you guys to know regularly. This is the welcome I sent last week before classes got canceled. So you got a week extra break. Let me see. Okay. So syllabus and calendar will be in this button right here where it says syllabus and calendar. If you click on this, you'll see, oops, connection is bad, sorry. There we go. You'll see the syllabus and calendar for the course. The calendar contains like the sections we're gonna cover, the order we're gonna cover them in, and it also has the exams. You're gonna see the date, the exact day we're gonna take a test, and what it's gonna cover. So you're gonna know that way beforehand, since everything is already listed. Although keep in mind, everything in the calendar is probably gonna be a week off, since we started lecture a week late. Let me see. Also, I hope you didn't have trouble finding the Collaborate Ultra link. I put it right here, but since you obviously joined the session, you probably already figured that out. But I want to click on it real quick just to show you something. This right here, what you see now, is where our classes are going to be held. But if you click on this menu right here and click on recordings, this is where you'll see the previous sessions we had. It usually takes about a day for it to pop up. So for example, this session right now, we're recording, you're gonna see it up here maybe tomorrow evening or so. But yeah, so if you ever miss a class, it's gonna be recorded and it's gonna be available for you to watch. Also, I usually have my own set of notes. So in course content, if you come here, you find lecture notes and chapter 1 notes. I just posted a few of them. This is the one, oops, I clicked on it. This is the one we're gonna see today, 1.2 linear equations. And these are the other two we're gonna cover on Thursday and Tuesday next week. I'm gonna continue adding all the chapter notes you're gonna need. My notes are inclusive of everything I want you guys to learn. So you technically don't need the book, but you do need the access code. So if you choose to purchase the book with the access code, that's up to you. But all you need for me, for my class, is just the access code. But I believe this section, if I'm not wrong, is part of Open Book Plus, which is something the Central Campus has arranged for students. So that's like it's worked into your tuition. So you don't need to buy the book or any access codes for this section, if I'm not wrong. And so I want you guys to try it out with me to make sure it works. Open up a window in your browser and go to the LLeaks website, because that's where your book is going to be, right? So right here, this is my username and password. You're going to have your own. If not, you're going to click sign up. And once you do that, you're going to use the course code for this section, which I have right here. Go to course content, and you're going to see it written down. Course code, this right here. So you're going to copy that, first part, second part. You're going to copy them and place them here. Once you do that, you go through the sign up process and it should allow you to enroll in the course automatically. So it's not going to ask you to pay, basically. And from there, you'll be able to see your homework and everything. So if anyone encounters any problems, just let me know. I think that's everything you need to know as far as the technology part goes. Like I said, course content, lecture note go here. And if I have any exam reviews, I'll post them right here before the test so you guys could practice a little bit. Exams are going to be on Blackboard, but we'll talk about that once the time for exams approaches. Does anybody have any questions so far? No? I'm gonna take your silence as a okay, good. If I ever like during lecture, if my voice cuts off or you stop seeing what I'm writing, or for some reason the internet is choppy, just let me know. Make sure I just don't keep going without you being connected with me on the line. Let's see. If I share. Oops. Okay. So do you guys see the piece of paper? You see the camera in my hand right here? Yeah? So this is what I'll be lecturing. I'll be writing down everything I say and explaining it as we go. So this is kind of like if you're in class and the instructor is using a DocCam, similar idea, and I hope this helps. Again, well, helps you understand what we're gonna do. Okay, let me see. Yeah, seems to be running smoothly. Okay, so, oh, one more thing. I wanted to tell you guys that in the comments here on chat, if you want to let me know that the screen froze or that I'm lagging or you're lagging for whatever reason, make sure to type the time you sent the message along with your message. That way I'll know how long it's been out. Because if you disconnect, I'll see it when you get back and I'll know you've been off for 5 minutes. But if I disconnect, I won't know. So when I see the message, I need to know when I disconnected. Does that make sense? So make sure you write down the time you lost connection, you stopped hearing me, or it froze. So keep me updated. That way we can keep the lecture going correctly and smoothly. All right. So now I'm going to start this section. So today we're doing section 1.2. Okay. So in this section, we're going to be talking about linear equations. So these equations are basically equations where you have the variable to the first degree. And by that, I mean, you're going to have x to the first power. You're not going to see x squared. You're not going to see x to any other power but 1. And you're only going to have the one variable. So we're using single variable. You can have more than one x in the same equation, but as long as it happens to be the same variable and all of them has the power of 1. Yeah? So let me give you an example. Welcome there. So this is number 1 in the notes. Question says, x plus 4 times x minus 5 equals 4 times x minus 2. All right, is this handwriting big enough, small? You want it bigger? Is it clear? Okay, great, awesome. All right, so now to solve any linear equations, first thing you need to do is get rid of what I call complications, right? So you need this equation to look in the simplest form possible. So to do that, first thing you need to do is get rid of these parentheses, right? So you have a multiplication of one number times a pair, once here and once here. So this is actually one of the very the easiest complications you can deal with. All you need to do is multiply the 4 inside, and the number of times you multiply it is depending on the number of terms inside the pair of parentheses. So for example, over here we have 2 terms. You have the x and you have the 5, so you're going to multiply the 4 twice. Once to the x, once to the 5. If you had 3 terms, then you're going to multiply 3 terms. Make sense? So the first term x goes down as it is. I didn't touch that. No. Plus Now multiplying the 4 times the x is going to give you 4x. And multiplying the 4 times the negative 5 is going to give you negative 20. All right? Equal. Now we're dealing with the other side. We have 4 multiplied by 2 terms, so it's going to be 1, 2. 4 times the x is 4x. 4 times the negative 2 is negative 8. So far so good. Once you get to this point, you need to think about combining likes. So basically, all your x's or your variable has to be on one side and the numbers on the other. Now, it doesn't matter which side you choose. So, excuse me, if you want the x's to be on this side and the numbers to be on that side, or the opposite, they're both fine. So for example, over here, let me add these up really quick. X plus 4x gives you 5x minus the 20 equals 4x minus 8. I didn't touch that side. Now, 4x, I'm going to move it to this side. And the negative 20, I'm going to move it to that side. Now again, if you chose to do the opposite, you're going to end up with the same result. So moving the 4x to this side, you have 5x minus 4x equals positive 20 minus 8. So did you notice negative 20, when we moved it to the opposite side, it became positive. So whenever you switch sides, you always flip the sign. So over here you have subtraction between 5x and 4x. That gives you 1x. And 20 minus 8 is 12. That's the answer. Now you can give me the answer in this form of x equals number, whatever the number is, or you can draw this squiggly brackets and write the 12 inside. This symbolizes a set. So you're telling me that the solution set for this question is this one specific number, and it's only the 12. Okay? Now, keep in mind that every single time you want to give me an answer to any equation I ask you, you're always going to have it in the form of x equals, right? 1 positive x. So this can't be 2x or a negative x or 1/2 x. It has to be 1x and it has to be positive. Go to the other side. So good? Oh. Okay. Let's do the second example. Now in this one, I'm going to be a little bit more mean. So I'm going to give you decimals. Now, usually in my sections, when I call a question fun, my students groan because that means it's going to be a little bit more difficult or more complicated. But that's what makes math fun, no? I can already imagine everybody shaking their head. But yeah, let me, oops. Okay. So as you can see in this equation, we have 0.6x minus 1.3 equals 0.2 times the pair of parentheses, which is 5x minus 8. Yeah? Now, you have two options here. One, you can solve it as it is with the decimals, which is doable, and that's actually how I did it in my notes. So if you want to look at that option, you can simply look at the notes. The second one is you could get rid of the decimal, and that's what I'm going to do here so that you could have an example of each method in your notes, right? So I'm going to do this one here, and the other one is already in my notes. That way you get to see both. So we'll get rid of the decimal points. Now on the side here, I'll give you a little explanation. Usually, when you have a number with a decimal, like for example, 0.13, and you want to get rid of the decimal point, you need to move the point a certain number of times until it follows any number that's significant, right? So you have 1 and 3 here, so you need to move it 1, 2. You moved it twice. So in order for this to happen, 0.13 needs to be multiplied by 100. Now notice, I multiplied it by a 1 followed by the number of points I needed to move the decimal in zeros. So 2 zeros because I needed to move it twice. So if I gave you 0.713, that's 3 numbers, right? That means I need to move the decimals 1, 2, 3 spaces, which means the 713 or 0.713 needs to be multiplied by 1000. So that 3 spaces, 3 zeros. 4 spaces, 4 zeros. 2 spaces, 2 zeros. So over here, how many spaces do I need to move these? The 6.6 only need to be moved once. 1.3 decimal only needs to move once. And the 0.2 also needs to be moved just once. So they all need to be multiplied by 1 followed by 1 0. So 10. I'm going to multiply the entire equation by 10. Now keep in mind, anything you do to one side of the equality, you need to do to the other side of the equality. Which is why I drew these big brackets here. Okay, so now I'm multiplying this 10 to this side and to that side. Yes. Yeah, all of the session be posted and it will be recorded, which I believe we are recording it. Yeah, so this session is already being recorded, so everything I'm writing down here, everything you're seeing, everything I'm saying is part of the recording, and you'll see it on Blackboard. But like I said, it takes about a day to be posted, right? So once this session ends, you won't see it right away, maybe tomorrow evening or so. But yeah, you'll also find a solved version of my notes. Like right now on Blackboard, the blank copy of my notes are up there. But I have a solved set of notes where you can see, like this is the first example we did. You can see it's solved step by step, so that should help you study as well. But yeah. Okay, back to this. So now we're multiplying the 10 times every single term. So that means 10 is going to get multiplied times the 0.6x times the 1.3 and times the 0.2 multiplied by this. Since there's a multiplication right here, that means you consider this whole thing as one term, right? So I'm going to multiply the 10 times the 0.6x. So this becomes 6x because I moved the decimal point one space. Minus. Now 10 gets multiplied by the point 1.3. So you move that decimal space by 1 and you get 13 equals. Now over here, 0.2, you also move the decimal place by 1. So you get 2 times 5x minus 8. Now here's a question I get often. Why didn't you multiply the 10 times the pair of parentheses right here? It's because this pair of parentheses was multiplied by the 0.2 as it is. So the fact that I multiplied the 0.2 by the 10 and turned it into 2, that automatically multiplies the pair of parentheses because I'm gonna multiply the 2 in here. Does that make sense? So if you multiply the 10 here, and then you multiply the 2 in there, you kind of multiply the pair of parentheses by 10 twice. Make sense? So you only do it the one time. Okay. So now I'm gonna get rid of this complication right here, which is 2 times this pair. So 2 gets multiplied in here and in here. So this side I'm not touching, so it's going to remain exactly the same. 6x minus 13. That one, you get 2 times 5x. Oh, it froze. Yeah, okay. So you have 2 times 5x, which is 10x, and then you get 2 times negative 8, which is negative 16. Now, I need to move the x's to one side and the numbers to the other. So let's move the 6x to this side and the negative 16 to the opposite side. Yeah? Doing it this way, like technically you can move the 10x here and move the negative 13 here, which is the opposite of what I did. But if you do that, then the bigger x variable becomes the negative one. So the result of the addition or subtraction between these two gives you a negative number. Moving the smaller one to the bigger one makes it easy on you. Does that make sense? So I'm moving the 6 to the 10x, and I'm moving the negative 16 to the negative 13. So you end up with negative 13 plus, since it was negative, plus 16 equals 10x minus 6x. Yeah? So over here, you get what? 10x minus 6x, which is 4x. And over here, we have negative 13 plus 16, which is positive 3. Divide by 4, divide by 4. And by dividing by 4, this becomes 1. So on this side, you have x. So that's your answer. X equals 3/4. So you can give me the answer like this, or like this, as a set. Either is acceptable. Does anybody have any questions? We're good? I'm gonna take this as a yes. Are you guys still with me? Just like give me a yes so I would know that you're here, that I didn't disconnect somehow. Okay. Okay, good, good, good. Awesome. All right. So, let me put this away. All right. So now let me give you guys a little example that to demonstrate the type of equations a linear equation can be. There's 3 types. The first one is called a conditional. Could we write answers in decimal form, or is fraction what you prefer? You can write whatever you want. So it can be decimal, it can be fraction, like the 3/4, for example. If you give me the answer as 0.75, you're definitely welcome to. Just make sure when you convert, you do it correctly. But other than that, yeah, do whatever you want. Although in the homework, it might actually have a preference, so make sure to pay attention to like the instruction of the question. Sometimes they say, like write the example in fraction form, or sometimes they might say, go ahead and write it in decimal and round up to the nearest 2 decimal points, for example, stuff like that. So make sure you follow the instructions of the question. So back to type of equation. So over here, this is the first type of equation, which is the conditional. And that's kind of the type of equation we already looked at. The first 2 examples were conditional equations. So in order for an equation to be conditional, that means you can only have one solution. So for the equation, when you have 2 sides of the equality, these 2 sides can only be the same if you use one very specific x, right? Therefore, that equation can only have one solution. So in the example we just saw, where x was 3/4, if x wasn't 3/4, like if you plugged x equal 1 instead of 3/4, then the right side and the left side would not match. Does that make sense? So the equation works, the equality checks out only if x happens to be one very specific value. Therefore, it's conditional. Does that make sense? The second type is called identity. This is the identity equation. So in order for an equation to be an identity equation, I forgot the N, identity equation. So in order for it to be an identity equation, it has to have infinitely many solutions. That means that any x you plug into that equation will make it work. Make sense? So whenever you get an identity equation and you simplify it as far as it could go, you will end up with the result 0 equals 0 every time. Let me give you an example of what an identity equation looks like. This is number 5 in the notes. Okay, here you go. Say you have 2, big bracket, times 4 plus 2 times 5 minus x minus 2x, close bracket, and it equals 4 times 7 minus 2x. Okay, now let's look at the left side since it looks a lot scarier than the right one. Over here, you have this 2 and these 2 brackets. So these two brackets means that this 2 is multiplied to every single thing on the inside. Now I have three terms, the 4, the pair of parentheses multiplied by 2, this whole thing is just one term, and then you get the 2x. So basically each term is separated by an equality or subtraction. Sorry, that's addition or subtraction. So addition and subtraction right here. If it's a multiplication like between these two, then those are considered one term. Make sense? Now, you have a choice. You can either multiply the 2 in first, so I'll multiply it to here, multiply it here, and then multiply it here. Or you can multiply this one into the pair of parentheses first, and then multiply the 2. Whichever one you start with is fine. It's going to give you the same result. In my notes, I did the one on the inside first. So in here, I'll do the opposite and start with the one on the outside. That way you can see both. Okay? So we have a 2, and we want to multiply it to every single term. Let's do that. So it gets multiplied here, and it gets multiplied here, and it gets multiplied here. So 2 times 4 is 8. Plus 2 times the 2 is 4, and therefore is multiplied by the 5 minus x. Minus 2 times 2, which is 4 with x. So it's negative 4 because it's a negative over here. Yeah? So this is my left side. I'm not going to touch the right side yet, so I'm just going to leave it. Oops, x as it is. Okay? Now, we still have pair of parentheses, so let's multiply the 4 in. First term, the 8 remains the same. 4 times 5 is 20. 4 times the negative x is negative 4x. And the negative 4x remains the same. Equals. Now, we have 4 multiplied by a pair of parentheses, so we're going to multiply it in. 4 times 7 is 28. And 4 times the negative 2x is a negative 8x. What do you notice about these two sides? I'm going to give you a minute. See if you can spot it. They're the same. And yes, they cancel out. You're both correct. So as you can see, over here we have 28 and a negative 8x. Over here we have 8 plus 20, which is 28, positive 28. And negative 4x and negative 4x, which is negative 8x. You see that? So the fact that they're both the same means I can subtract the 28 and subtract negative 8x from both sides, and you end up with 0, 0 if you want to work it out. But as far as I'm concerned, if you get to this point, you technically solved it. Like that's what you need. Now, here's the reason we say this type of equation is considered an identity equation. It's because any x, and I mean any x, literally any number you could think of, if you plug it in here and plug it in here, both sides are going to be identical. Why? Because they are identical, right? So if x is 0, this cancels out, both sides are 28. If x is 1, then you get 28 minus 8, and it's 20 in both sides. Make sense? So any x you choose is going to make the same difference on both sides. Does that make sense? So it will always be the same for both, which is why we say this is an identity equation, and that it always equals 0, 0. So when you get to this point, just tell me that. Tell me it's an identity equation, and if you get to this point, as far as I'm concerned, you got the question right. Make sense? If you give me this, even better. Yeah? Because this type of equation, you can't just say x equals because there's no number. You just tell me it's an identity equation. All right? Now to the third part, third type of equation, number 3, which is a contradiction. So what is a contradiction? This type of equation is when you have no solution. So a conditional equation is when one very specific x gives you the solution for that equality. An identity is where you have infinitely many. Any x you could think of will work. A contradiction is the exact opposite. Oh, it did. 627. So that's right when we talked about both sides of the equation canceling out. So an identity equation, like I said, if both sides are identical, then it's going to give you 0, 0, which means that both sides are exactly the same, and they're going to give you infinitely many solutions. X can be any number. That's an identity equation. And when you want to submit the solution, just tell me it's an identity. If you get to this point, you got it right. If you get to the point where both sides of the equality are the same, you got it right. Okay? Now we're talking about a contradiction. A contradiction is the exact opposite of an identity equation. For this one, there is no solution. No matter what you do, any x you think of, the equality will never work because the right side and the left side will never match, ever. So let me give you an example of a contradiction. This will be example number 7 in the notes. So for this one, we have -3. Sorry. We have -3 times x minus 2 plus 4 times 2x plus 5, and it equals 10x minus 5x minus 23. Okay? So this is the equation I'm giving you. Now, on the left side, we have 2 pairs of parentheses that need to be multiplied by a number. And the right side, we have 1 pair. Let's start with the left one. You have -3. Make sure to include the negative in your multiplication. So negative is here, and it's multiplied here. -3 times x is -3x. -3 times -2, both negative, gives you a positive result, and 2 times 3 is 6. So far so good? Now, plus, let's do this one. We have 4 times 2x, which is 8x. 4 times 5, which is positive 20. Now, let's do the right side. The 10x goes down the same, nothing to do here. Now, I don't have anything to multiply here, so do I just write this as 5x and 23? Just basically remove the parentheses. Does this look right? I made a mistake here. Can anybody tell me what it was? Yes, it has to be positive 23. Why? Because over here, even though you don't see a number, you have a negative sign. So essentially, this is -1. I'm asking you to multiply the pair of parentheses by -1, right? So if you multiply this in, the 5x does end up negative, that's true. But you're also multiplying a negative to the -23, which turns this to positive. Make sense? So never remove the pair of parentheses before making sure that the multiplication carries out. Okay? So now you have -5x and positive 23. Okay. So on this side, we have what? -3x and the positive 8x. Together, those are positive 5x, right? Subtract 3 from the 8, and it gives you 5. Yeah, 5x. Now you have positive 6 and positive 20, which is 26. Now let's look at that side. Here we have 10x minus 5x, which is 5x, plus 23. Now do you see the difference between the two sides? The term where you have the variable x, they're the same. You have 5x in both, which means that any x you choose will end up causing the same effect on either side. If I put a 1, then you're going to have 5 times 1 for both sides. It's going to be 5 for both. If you put a 3, it's going to be 5 times 3 for both sides. Make sense? So these are going to be identical no matter what. They can cancel out. The problem is that you're adding numbers that are different. You see that? You have 26 and 23. So you're essentially saying 26 equals 23. And that will never happen. Make sense? Which is why this is a contradiction. These two sides are actually not equal. So this is a contradiction. So when you encounter such a problem, you either say no solution, or you draw an empty set. So this is the solution set, and as you can see, it's blank. Now, it being empty does not mean it's zero. If it's zero, you're going to write down the number zero, so don't ever confuse those two. When it's empty, that means there's no solution. Okay? Anybody have any questions? Okay, I'll take that as a no. Right. Let's keep on. Right, now I'm going to do a few rational equation problems. The difference between an equation with a fraction in it and a rational equation is the placement of the x. For example, if you see a question where you have 1/2 times x, this is not a rational equation. This is just a simple equation where x is multiplied by a fraction. If you see this, that's the rational equations. In order for the equation to be rational, the x has to be inside the denominator. Make sense? So the fraction has the x on the bottom instead of just next to it. So let me give you an example here. This is number 8 in the notes. We have 9/4. My 4 looks like a 9. Anyway, 9/4 minus 1/2x, which equals 4/x. Right? So whenever you're attempting to solve a rational equation, there's one tiny step I need you to do before you start solving it. Every single time. Whenever you see x on the bottom, this is what you must do. I want you to grab the denominator and set it equal to 0. And then solve until you get x equals. In this case, it's just an x, so x does equal 0. We're done. For this one, it's 2x, and it equals 0. So I'm going to divide by 2 on both sides. But, 0 divided by whatever is still 0. So the answer for this one is also x equals 0. So it's the same as the other one. You don't need to give it to me twice. If it's the same value, one is enough. So keep in mind the value x equals 0. Now, why did I do this? It's because I basically grabbed the value in the denominator, and I'm saying that this is the value x cannot be. Okay? Because whenever you have a fraction, you can never divide by 0. So if I want you to divide anything, any value by a number or a variable, that variable must not be 0. Yes, yes, ma'am. So if I give you, for example, 5/x, then the x cannot be 0 no matter what. Now, why do I tell you to do this? It's because I want you to avoid the solution being this number. And I'll show you more examples on this in a second. Okay? So let's solve this example first. We have 9/4 minus 1/2x, which equals 4/x. Now, whenever you have anything in the denominator, whether it's x or just a number, how do you get rid of it? Like, how do you get rid of the denominator? Because as far as you're concerned, having something in the denominator is a complication. So first step in solving any equation is getting rid of the complications. So in this case, you basically multiply by the opposite, right? For example, if I gave you 1/2 and I want to get rid of the 2 on the bottom, you multiply by 2, correct? Because that way they cancel out. If you have 2x and I want to get rid of the 2, you divide by it. So division and multiplication cancel each other out, which is the idea here. Since I want to get rid of the x on the bottom, what do you think I'm going to do? I'm going to multiply the equation by the variable on the bottom. But now we need to figure out what to multiply the equation by to get rid of everything in the denominator. Because we have 3 distinct ones. We have a 4, we have 2x, and we have x. So let's think it out. If I multiply by 1x, this cancels out, right? If I multiply this term by x. This term, you cancel out the x, but you end up with the 2 still. So what happens if I multiply by 2x? Over here, you end up with 2 times 4, and the x cancels. Over here, the 2 cancels, and the x cancels, and you just have the 1. And over here, 2 out of the 4 cancels, but you still end up with a 2. Now, technically, you can solve the equation once you do this. That's fine. But the easiest possible way to solve this would be multiplying it by 4x everywhere. If I multiply by 4x, I'm going to remove every single denominator here. So this is called your LCD, least common denominator. This is the least value that cancels out every single denominator you have. Okay? Now, here's one safe way of doing this without ever making a mistake or taking too long trying to figure out what to multiply by. You can always just multiply every single denominator you see by each other, and the result gets multiplied by the entire equation. Yeah? So you have what? X, 2x, and 4. You end up multiplying by 2x by the 4 and the x all together. The problem is, when you do that, you're going to end up with a far more complicated equation. It's still easy to solve, but it's going to be more work. So it's actually better for you if you try to figure out what your LCD is, which in this case, you figure out how to get rid of every single variable and clear out the numbers on the bottom. So to get rid of the 4, you multiply by 4. The 4 cancels out the 2, so we're still good. And to get rid of the x's, you have to multiply by x. Is everybody with me so far? Okay, good. All right. Now, I'm going to multiply the 4x here to every single term. Since I have 3, it's going to get multiplied 3 times. It's 1, 2, and that's a really long line, 3. Okay, so 9 over 4 times the 4x. That's the first one. Minus 1 over 2x times the 4x equals 4 over x times the 4x. Okay? Oh, that got blurry. Okay, there we go. So, first term, you have 4 over here and 4 on the bottom, so they cancel. And you end up with 9 times the x, so 9x. Minus, second term, you have the x's cancel, and the 2 and the 4, you cancel the 2 and you can get a 2 out of the 4. And 1 times 2 is just a 2. So you have 9x minus 2. Equals over here. Now, here's a mistake I see often. When the fraction resembles the number you're multiplying by, I often see people cancel everything out and give me a 1, which is incorrect, because you see this 4 gets multiplied times that 4. Does that make sense? Because this is not on the bottom, it's on the top. So you have the x's cancel, right? And you have 2 4s multiplied together, which gives you 16. Okay? So you have 2x minus 2 equals 16. Now we combine likes, so you grab the 2 and you move it to that side. And you have 9x equals 18. Divide by 9. Divide by 9, and x is 2. Or the set 2. Okay, now that we have the answer, I want you to look at the answer, the 2, and compare it to the number we set aside. Are they the same? The answer is no, so we're good. That's what you want to happen. You don't want them to be the same. If the answer was 0, then we would have had a problem. Make sense? Which is the exact same thing it's gonna do in the next example. So here we go. Quick question. Did you get the 18? Okay. So as you can see, we have a 2 over here. If you move it to the opposite side, it becomes positive 2. So 16 plus 2 is 18. Make sense? Okay. Now, let me give you one more. This is number 9. So in this one, we have what? X plus 6 over x plus 3 minus 2 plus 3 over x plus 3. Okay, so again, first thing you need to do is grab the denominator, set it equal to 0. In this case, my denominator is x plus 3. So I'm writing x plus 3 and then setting it equal to 0. And then you solve for x. So in this case, I'm moving the 3 to that side. And you end up with x equals negative 3. Okay. Now the other one is exactly the same, so you don't need to do it twice. It's the same number. So now the value I'm keeping in mind is negative 3. I don't want the answer to be negative 3. If it is, we're going to have a problem. So keep that in mind. Now let's solve this. And this one is actually pretty simple, or at least simpler than the first one, because what? We only have the one denominator, right? Both of them are exact same number. So what I'm going to do is multiply the whole equation by x plus 3, because that's going to cancel out this one, cancel out that one, and just multiply this one by x plus 2. Okay? Let's do that. So x plus 3 times the first fraction, which is this one, minus x plus 3 minus 2 times x plus 3, and it equals 3 over x plus 3 times x plus 3. Okay, so denominator with this pair of parentheses cancel. Over here, these also cancel. And you end up with the top, which is x plus 6 minus 2x plus 3, and equals 3. Yeah? So over here, you get a pair of parentheses, which is a complication you need to get rid of. So 2 gets multiplied in here. You have 1, 2 multiplications. Now the first two terms I'm not going to touch because there's nothing to do here. So x plus 6. Now keep in mind what you're multiplying is what? A negative 2. Yeah? So negative 2 times the x is a negative 2x. And the negative 2 times 3 is a negative 6. And the whole thing equals 3. All right. Now notice I have a positive 6 and a negative 6. So these two numbers add up to 0, right? So we end up with x minus 2x equals 3. Which is what? This is negative x, right? And it equals 3. Do I stop here? Okay, is this the answer? Negative x equals 3? No, because what did I say? If you remember at the beginning, we said that the answer should always be in the form of x equals, and it should always be 1 positive x. In this case, it's negative. So we have negative x equals 3. And I need to get rid of this negative. So all you need to do is multiply both sides by negative 1 or divide by negative 1. It's up to you. So you multiply both sides by negative. This becomes positive and that becomes negative. Now we can stop. That's your answer. You see a problem here. The x we got from this equation was what? The exact same number we were trying to avoid. X cannot be negative 3. So since that is the case, this is not an acceptable solution. Therefore, the answer for this equation is no solution. Yeah, so always remember to check for this once you're done solving, because if you don't do that, it is possible for you to do all the work correctly, arrive at the correct result, and then give me the wrong answer, because the answer is not negative 3, it's no solution. Make sense? Any questions? Okay. Let's go. All right. Now, Oops. Let's see. Oh, I forgot to mention this at the beginning of lecture. So let me do this right now before I forget again. Your homework. Again, your homework is on Aleaks, the website. The thing I want you to know is that every week your homework is going to be due. So, for example, today we're covering 1.2 and a little bit of 4.3 because that's rationals, which is what I just did. So those two sections are going to be due on Blackboard next Tuesday. So basically, every single time we cover a section in class, exactly 1 week from that class, that homework is going to be due. Okay? So what we covered this Tuesday is going to be due next Tuesday at midnight. What we cover next class on Thursday is going to be due the following Thursday at midnight, and so on and so forth. Make sense? So make sure you keep up with the homework. And if you have any questions, just let me know. All right. Now this is one of those examples my students call fun. I really like this one, but it's gonna be a little difficult to follow, so make sure you stay with me. The only reason I want to show you this one in class is because it shows a very specific type of example that I want to make sure you guys are exposed to. So have you ever wondered what happens if I give you an equation where the denominators are not exactly the same? Like the very first one, both were x's. There was nothing added. There was something multiplied, but it was minor. So we were good. The second example, I gave you x plus 3, but both denominators were the same. So I essentially gave you just the one type. So what happens if you have more than one, which is what we're going to see in this case? So you have 1 over y minus 1, and I'm just switching out the x for y, but that's about it. It's still one variable. So we have 1 over y minus 1 plus, on top we have y plus 1, and on the bottom we have y squared plus 2y minus 3 equals 1 over y plus 3. Okay, so as you can see, we have how many? 3 types. Now, since you have a quadratic in the denominator, I want you to factor it first. We're going to see more about factoring in chapter 3, but this is a skill. Factoring a quadratic into 2 pairs of parentheses is a skill you're supposed to know before you get to college algebra. So I'm going to walk you through this one a little bit quick. The reason we have a quadratic, something to the second power, even though we're technically dealing with linears, is because you can factor this one. So an equation where you have the variable to the second power is the result of the multiplication of 2 parentheses. And by parentheses, I mean something like this, like the y minus 1 and the x plus 3. You have one variable plus or minus a number, right? So 2 parentheses multiplied together give you this equation right here. So you should be able to break this down into those 2 pairs. Now to do that, you know you're going to have one y right here and one y right here because it's y squared. So you grab the first one and break it into 2. Now I want you to look at the last number of the equation, the 3, right? This number right here is the result of the multiplication of the 2 numbers that go in here, right? So the result of that multiplication is negative 3. Since the number is 3, you know 3 is a prime number, which means that multiplication can only be between 1 and 3. That's it. There are no other options. Like, for example, if this was 4, then it could have been 1 and 4, and it could have been 2 and 2. Make sense? But 3 is a prime number, so it can only be 1 and 3, nothing else. So I'm going to write 1 and 3. Okay, now I need to figure out the sign. The multiplication result is negative, if you had two negative numbers or two positive numbers multiplied together, the result will always be positive. The fact that it's negative, that means one of them is positive and the other is negative. Does that make sense? Now, which one is which? You will be able to tell by looking at the number right here. This 2, this positive 2, that tells you that the 3 is the positive one and the 1 is the negative one. Why? Because this number right here is the result of the addition of these two numbers. So if 3 was negative and 1 was positive, then adding negative 1 to positive, negative 3 to positive 1, that would have given you a negative 2. So since the result of the addition is positive, that means that the bigger number was the positive one. Does that make sense? So now we factor this equation into two pairs of parentheses. I'm going to rewrite this one right here into a fraction where you have these two multiplied together instead of seeing the quadratic. So we have y minus 1 and y plus 3 with y plus 1 on top. And it equals y plus 3. Here. Okay. Now, as you can see, we have two types of parentheses. This one and that one. This one right here is just these two multiplied together. Do you notice? Negative 1 and plus 3. You multiply them, you get that one, that quadratic. So now you need to do that little step we always do. You need to grab the denominator and set it equal to 0. So we have y plus 3 equals 0. Grab the whole thing. Equals 0. You move the 3 to that side, and y is negative 3. So this is the first number we need to avoid, negative 3. Second one is y minus 1 equals 0. Grab the 1, move it to the opposite side, and y equals positive 1. This is the second number you need to avoid. Okay? Now, do I need to do this one too? No, because this is the result of a multiplication. That means if this number was 0, the entire thing would be 0. And if that number was 0, then the entire thing will be 0. So I need to do them separately, which you already did. Make sense? So having done this, you don't need to repeat it because that would just be redundant. Okay, now let's think about the tedious part. How do we get rid of the denominators? Well, here's a hint. You always multiply by everything on the bottom, right? In this case, you want to multiply by whatever cancels this denominator out and whatever cancels that denominator out. Luckily, it happens to be the exact same thing right here. So if you multiply by y minus 1 times y plus 3, that will cancel out this one, and that one. Yeah? So I'm going to multiply by these two pairs. Y minus 1 and y plus 3. These two, both of them, get multiplied to each term. So the first one, we have y minus 1 times y minus 1 times y plus 3. This is my first term. Plus y plus 1 over the multiplication of both pairs and the bottom times multiplication of both pairs on top. Oops, y plus 3. Okay. And I'm going to write the right side at the bottom because I have no room right here. So equals 1 over y plus 3 times y minus 1 and y plus 3. Okay. Okay, let's start with the first one. We have 1 over y minus 1 times the two pairs right here. So the y minus 1 in the bottom and the one of the pairs we multiplied are going to cancel out. Okay. So you're going to end up with 1 times y plus 3, which is what you write down. Plus, now, you have y minus 1 and y plus 3 in the bottom and in the multiplication. So you just cancel both out. And you end up with the result on top, which is the y plus 1. And lastly, last term, you set the equal sign. You have 1 over y plus 3 times these two pairs. So y plus 3 and y plus 3 cancel, and you end up with y minus 1 times 1. Oops, I think it got stuck. Oh, there we go. You end up with y minus 1 times 1, which is just y minus 1. Now let's combine legs. We have 2y, these two add together, and 4, right, equals y minus 1. I'm going to move the y to this side and the 4 to that side. The y turns negative, so you have 2y minus y equals negative 1 minus 4, because the 4 turns negative as well. So you have y equals negative 5. And that's your final answer. Now, we have to check. Let's look at these two. Negative 3 and positive 1. And this is a negative 5. So we are good. That is your solution, negative 5. All right? So that is it for today. So let me see. If you guys have any questions, just let me know. Wait a few seconds while I make sure I get a record of the names. If you get any trouble logging into your homework or you have any questions, just let me know. My email address is available on Blackboard in the syllabus. And I'm sorry, let me see. Question. Are you going to post homework on announcement? No, homework is going to be on Elix. If you want me to post like reminders, remember to do your homework and stuff, sure. But really, you have homework due every Tuesday and Thursday, and it's going to be the section we covered the previous week. So it's a consistent thing. It's not it's not that difficult to follow. Return assignments. Do we attach our work to it? No, you don't need to do that. Luckily, the assignment is online, so you solve the problem as fast or as slow as you want to, and once you're done, you input the answer, and if you get it right, that's as good as I can ask for. So you don't need to show me your work. Just it gets graded automatically through Elix. I will just make sure to maintain your grades. So that's about it. Any other questions? All right. If you're done, log off, and I'll see you guys later. Is there homework for last week? Okay, no. Since classes got canceled last week, there's nothing for you to worry about. Like, technically, today was our first lecture as far as the class is concerned. I already went ahead and moved the due dates by a week. So today we covered 1.2 and 4.3, and they're gonna be due on Tuesday next week. Make sense? So don't worry about last week. All right, awesome. See you guys later.